Hi guys, welcome to the session. Hi Himanshu, I hope you're there. A very warm welcome to all of you. So today we're going to be getting started with integrals. So primarily we have 4 sessions for integrals. Today we're going to be doing indefinite integrals. In next 3 sessions we'll talk about definite integration. Hi Sahil, hello Mukund, welcome to the session guys. So let's get started without any delay. Over here, if I talk about, good evening Amitesh, if I talk about the weightage of integration in JEE Mains and Advanced. So you may say, look, in JEE Mains, or JEE Main for that you say. So in JEE Mains, you can expect 2 to 3 questions from integration. This involves definite as well as indefinite. 2 to 3 questions, right? Hello and welcome to the session, guys, every one of you. So this is what the story is in mains. If I talk about advanced, JEE Advanced, you can still expect 3 to 4 questions from here. 3 to 4 questions from here. So basically, this consists of around 8 to 10% over here of the paper, and this turns out to be around 8 to 10% again. 8 to 10% again in JEE Mains. Okay. So this involves the definite as well as the indefinite. Definite and indefinite. Right. All right. So all of it, let's get started. Most of us are here, which is really good. Good energy out here in the session. Before getting started with any other thing, let me just tell you one, or let me ask one question, quick question. So let's say I am asking you to integrate x plus 1 dx. Well, I hope all of us know how to do it, right? All of us know how to do integrate x plus 1 dx, which is kind of simple. Sanjay, it's okay. You can come back and see the recording. So x plus 1 whole square. I can do it by 2 methods. Let me tell you. One of the methods is I can put it like this. So integration 1.dx plus 1.dx, right? And then I can say this is basically x squared upon 2, and this is nothing but x plus c. This is one of the choices. Very good, very good. Acha. On the contrary, if I again solve the same thing in a different format, I'll say, okay, look, we all know about it though. Yeah, this is just a linear term. In a linear term, we can directly integrate, or we can apply the integrations. We can say this can directly be written as 1 plus x plus 1 whole squared upon 2 plus c, isn't it? If you calculate this further, oh my God, it's a wrong question. Okay. So divided by 2, it's not incorrect here. Now, in this case, if you see, this is x squared upon 2 plus x plus half plus c. What do you think? This answer, I believe, is different from this one. What do you think? You can probably, So you may find things like this in integration, that your answer is different, or it seems to be different from the answer which is there on the screen. Sanjay, can you tell me what is incorrect in the question, if at all you can? Right. Okay. So very nice, very nice. However, over here, the answer, both the answers are exactly the same, So at times we tend to get different answers. However, eventually those answers turns out to be the same. So if you see this is just another constant k, right? Or maybe another c, or capital C, if you want to refer it as c. So both the answers are exactly the same, x squared upon 2. So it's our way of how to see the integration story, right? I hope everyone is clear with it. So both the answers are exactly the same. Very nice. Okay. In today's lecture, what we're going to be doing is we'll precisely be talking about 2 particular types of questions. One is when we have, I'll just put it over here. See, one wherein you have something like this. If you have something like this, dot dx. If you want to integrate 1 upon x times x to the power n plus 1 dot dx, or if you want to integrate something of this sort, x squared times x to the power n plus 1 to the power n minus 1 upon n, right, dot dx. Or you need to integrate 1 upon x to the power n, x to the power n plus 1 raised to the power 1 by n, right? In all the three types, such types of methods, such types of forms, right? So it's just one form. In all such forms, what do we need to do? We'll take x to the power n common from the bracket. So from each of these brackets, we'll take x to the power n as common. And then what will we have if I take x to the power n as common? In the bracket, we'll be left with x to the power minus n plus 1. We'll assume this to be some t. So step 1, and this will be the second step. Thereafter, you'll get to know what to do, right? So for all such type of questions, we'll do this type of substitution, right? That was a correct question. Let's take up an example. So this is a JEE Mains 2015 question. Integration of dx upon x squared times x to the power 4 plus 1 to the power 3 by 4. So if you see, this is similar to the type which we have just discussed. This is 1 upon x squared times x to the power n plus 1 raised to the power n minus 1 upon n, right, dot dx. That is this form. In this form, what do we usually do? In this form, we take x to the power n as common. Because this is a session on that, Sanjay. Do not digress, do not deviate. If you want to attend the session for JEE Mains, fantastic, or else you may leave. So over here, Sonia, I hope you're not facing any problem. So over here, what will we take? We'll take this x to the power 4. N is 4 over here, right? So this is n minus 1, 3 over here. We'll take x to the power 4 as common. I'll just quickly do this question. So over here, we have dx upon x squared, x to the power 4 plus 1 to the power 3 by 4. If I take x to the power 4 as common, x to the power 4 as common. So we have x squared. We'll take x to the power 4 as common. Because there is a power of 3 by 4, so we need to raise it to the power 3 by 4. We will be left with 1 plus 1 upon x to the power 4. Whole stuff to the power 3 by 4. I hope all of us know how to take common. Now, this is a step which is kind of redundant. You can skip this step and eventually write the final thing over here, right? Sanjay, I've given the concept. I've already told you that whenever you have such type of integrations, in that case, always take x to the power n as common and then put x to the power minus n plus 1 is equal to t. That's it. That's it. So over here, this 4 and 4 gets cancelled out. This turns out to be 2 to the power x to the power 2 times x to the power 3, which is x to the power 5. And this can be written as 1 plus x to the power minus 4 whole stuff to the power 3 by 4. So we have generated one of the type of integrations which we have done. So over here, what will we do? We'll assume this to be t. We'll assume this to be t. Very good, Sachin. Very good. I hope that is correct. And then I'll integrate, I'll differentiate it just to remove this dx and put dt over there. So we'll get minus 4x to the power minus 4 minus 1, which is minus 5 dt. Right? So this turns out to be dx upon x to the power 5 is equal to dt upon negative 4. I will just replace the method. We will just replace the dx. So this again equals dt upon dx. Oh, sorry. Yeah, dx upon x to the power 5 can be replaced by dt upon minus 4. So it's like dt upon minus 4. And this turns out to be t to the power 3 by 4. Which is kind of simple now. So this is negative 1 by 4. And then we need to integrate this, which turns out to be t to the power 3 by 4 plus 1 minus 3 by 4 plus 1, which is 1 by 4 upon 1 by 4. Right? This 4 and 4 gets cancelled out. It is negative t plus c, obviously. To be more precise, we'll get negative t to the power 1 by 4 plus c, wherein t is nothing but 1 plus x to the power minus 4. So this turns out to be the answer to the question. If you want to expand it, as soon as you can expand, you will have your answer as D. Now, indefinite integration gives you a Option 2, go by the options as well. Option 2, go by the options as well. Sanjay, I can't share that. What do I mean by that? You can choose the options over here and you can try and differentiate these options to get the integrand. Whichever option gives you the integrand, that will be the answer to the questions. You can also go ahead with that. It will also not take much time, at least in such questions. Right? So you can integrate the first one or the second one or the third one, and eventually you can figure out what the answer is. Right? When we have limits, we call that integration as a friendly equation. Okay. So let's try one more question on it. This is again a JEE 2006 question. JEE 2006 questions. So this is what you need to calculate. Over here, for all such questions, again, we can take x to the power n common. So over here, we'll take what? We'll take x to the power 4 common from this square root. From this square root. What will we have? X square minus 1 upon x cube. And this x to the power 4 taken as common, because there is a square root, will have x to the power 2 outside, right? X to the power 4 whole stuff to the power 1 by 2. And over here, you will have x. So 2 left as it is. This is 2 to the power x to the power minus 2, right? If I divide it by x to the power 4, I'll be left with x to the power minus 2 plus x to the power minus 4. Nibaksh, we are giving you the same sort of lectures, you may say, because these are previous year questions only. And if you wanted specific lectures, you may contact the Meritnation team. They'll let you know about that. All right, so over here, how to go about it? I've just taken again what common? X to the power n. The highest degree term over here, I've taken it as common. But हम यही करते हैं. We'll take x to the power n as common to solve all such questions. So over here, we can have, this is x to the power 5. I hope all of us can analyze. So I can write it as, I can shift this x to the power 5 to the numerator. It will be somewhat like this. In the denominator, we have 2 minus 2x to the power minus 2 plus x to the power minus 4. Right. Now, in this case, what will we do? We'll assume whatever we have within the bracket equal to 0. Equal to t, not 0. We'll assume this to be t, right? Sanjay, because that was the plan. What is the issue? So we'll differentiate this dot dx. I hope all of us are comfortable with this dt. So taking x to the power n as common. So we have x to the power minus 3 minus x to the power 5 dot dx is equal to negative 4. When being taken as common, you can put it over here as negative 4 in the denominator, right? Now, if you see, x square upon x to the power 5 was nothing but x to the power minus 3. This was x to the power minus 3. And this was x to the power minus 5. X to the power minus 5, right? And I hope all of us can see that this times dx is nothing but dt upon minus 4. So we can replace the same over here to get down to the answer. So this is dt times dt upon negative 4 square root of t. This was t square root of t. I hope this is fine with all of us. So this is negative 1 by 4, and integration of t to the power minus 1 by 2 gives me t to the power 1 by 2 upon 1 by 2. So this gives us our final answer as 1 upon 2 t to the power 1 by 2 plus c. T was this, which is the square root over here. We'll replace the value. We'll have the answer as, just a moment. Sorry, this is plus, no, this is plus, and this was also. Did I do any mistake? Wait a minute. This was plus, this was plus. We have taken plus 4 as common. This was plus, we have taken plus 4 as common, we'll get this. So this was plus 4. This was plus 4, plus 2. Hence the answer to the question is 1 by 2, t is this. It is C. Right? Yeah. But eventually you will be able to analyze Sachin that, you have sort of done some mistake because the answers won't match maybe. So then you can just quickly cross-verify. However, you shouldn't do these silly errors. in the actual test. Okay, so I hope this is fine with all of us. Again, what we did over here, we took the highest degree term common. Let's see one more question. These questions are common in JEE Mains 2016. We again have a similar question. So again, what we will do, we'll take x to the power 5 as common from the denominator. So over here, we'll take x to the power 5 common, right? What will we get? 2x to the power 12 plus 5x to the power 9 divided by, yeah, we will talk about, we are, in fact, we have taken one question from JEE Advanced only, which was of 2016 or 2006. So over here, we can take x to the power 5 as common. What will we have eventually? X to the power 5. The whole stuff has been raised to the power 3. So this whole stuff has been raised to the power 3. What are we left with? Over here, 1. X cube upon x to the power 5 gives me x to the power minus 2. So I'll write x to the power minus 2 over here. And this gives me plus x to the power minus 5. Whole stuff to the power 3 dot dx. I believe everyone is clear with it. So what we have done, we have taken x to the power 5, the highest degree term, as common. Now, if you see, if I take this x to the power 15 and divide by these two terms, so what will we have? We have x to the power 15 over here, x to the power 9 upon x to the power 15 over here, divided by this entire term which we have dot dx, right? Pratap, because this is a type of question which you see here and there, wherein a common substitution or a common method is step 1, take the highest degree term as common, then take that term to the numerator. Usually, in most of the scenarios, what you get is you get this term as the derivative of the term in the denominator, Pratap, right? So that's why we take this method. That's why we use this method. Over here, what we can say, look, if you see, this is 2 times x to the power minus 3 plus 5 times x to the power minus 6. Minus 6. Now, if you see, this is nothing but the derivative of whatever is there within the bracket of the denominator. If you see, 1 plus x to the power minus 2 plus x to the power minus 5, if I assume this to be t, what will I have? Minus 2x to the power minus 3 minus 5x to the power minus 6 dot dx is equal to dt, right? So over here, we have exactly the same thing. We just need to take a negative common. That is it. 5x to the power minus 6 dot dx. This can be replaced by negative dt. Hence, what we have eventually over here is, it is negative dt upon t cube, right? So you can write it as negative t to the power minus 3 plus 1. I hope you know that. Minus 3 plus 1 upon minus 3 plus 1 plus c, right? So this turns out to be negative. Negative turns out to be positive. So you can write directly positive. So t to the power, this is 2t squared plus c, right? I hope everyone is clear with it. Negative will get cancelled out. T can be replaced eventually from here. Once you're going to replace t, take square of that. You will be able to get one of the answers. So let's calculate, because the answers are given in a different format altogether. So let's replace t over here with a different color maybe. So if I replace this over here, I'll do it over here. Just have a look. So it's a kind of simple thing now. T, which we have assumed, was 1 plus x to the power minus 2, which can be written as 1 upon x squared, plus 1 upon x to the power 5, whole stuff to the power 2, whole squared, plus c. This is what we were getting as a result. We can take x to the power 5 as common in the bracket, in the denominator. Basically, we are taking LCM, right? And 5 x to the power 5 whole squared can be taken to the numerator. So it is x to the power 10 twice of x to the power 5 plus x cube plus 1 whole squared plus c. So this turns out to be the answer to the question, right? Which I believe is given where? The very first option. Hence, A turns out to be the answer of the question. I believe everyone is clear with it. Okay, so I've told you, whenever you have such questions, in that case, you can take the highest degree term within the bracket of the denominator common, or within the square root of the denominator as common. Second type of distinct integrations which I want to talk about are of this type. Let me tell you this. And these are interesting ones and important ones. So if you have x square minus 1 upon x to the power 4 plus 1 type, right? If you have something like this, x square minus 1 upon x to the power 4 minus 1, or you have something like this, integration of x square plus 1 upon x to the power 4 plus 1 type, right? In both the scenarios, what we usually do, let's say in the first one, in fact, in both of them, we'll divide, I'll write it like this, divide numerator and denominator by x squared, right? That will be the first step. So if I talk about the yellow one, first of all, let's try and do the yellow one. So if I divide it by x squared, what will I have? 1 minus 1 upon x squared. And this turns out to be x squared plus 1 upon x squared. Yeah, by x squared. Correct. Right? In this case, obviously it is dot dx. In this case, we can see the denominator can be expressed as the integration of this, or you may say that this will be the derivative of something which you can generate in the denominator. What is that? I can write this as, it's a very simple thing to analyze. I can write this denominator as x plus 1 upon x whole squared minus 2. I hope everyone is clear with it. If I would like to explain this down over here, so see, this basically says, with a different color maybe, x plus 1 upon x whole squared is what? This is x squared. Yes, making the perfect square in the denominator. Absolutely, Pranjal. X squared plus 1 upon x squared plus 2x times 1 upon x, I'll just give me 2. Therefore, x squared plus 1 upon x squared can be written as x plus 1 upon x whole squared minus 2. Right? So this is the logic. Okay, so over here, why did we do so? Because in this case, if I'm assuming this to be t, I will be able to get over here 1 minus 1 upon x squared as the differentiation of this, derivative of this. This will be the derivative over here, dot dx. So we can directly replace it. So we can say, look, over here, if I want to replace it, or if I will replace it, we'll directly get t squared minus 2. And then it's a simple formula which we need to apply, right? This is a simple formula which we need to apply. 1 upon 2a log x minus a upon x plus a plus c, right? This is something which we all know how to solve. One more thing over here, if I talk about this blue one, over here again, I'll divide by x squares. What will we have? We'll have something like this. In the denominator, again, we are getting the same. But in this case, and this is something which you should remember always, or else you might make some errors. In this case, we'll try and convert the denominator in terms of a negative sign. What do I mean by that? I'll write it like this. Plus 2. I hope this is clear to all of us, including Pranjal and everyone, right? So over here, whatever sign we have in the numerator, we make the opposite sign in the denominator, because that's what we're going to have eventually when we are differentiating. So in this case, we'll assume x minus 1 upon x is equal to t. Yeah. So in this case, this will be 1 plus 1 upon x squared dot dx is equal to dt. Is that okay? And eventually you will be able to solve it. This is dt upon. Very nice. Very nice. So dt upon t squared plus 2. Okay. Now, these were basically the types which you're going to find. These two types are the types which you will find in some steps while solving a question on indefinite integration or definite integration, right? When you will solve, it will be a part in between. So what type of questions would you be actually seeing? Let's have a look on that. So in reality, you're going to have questions of this sort. Whenever you have questions on this sort, 1 upon, this is also sort of important. Something like this, or 1 upon x to the power 4 plus kx squared plus 1, or you have 1 upon x to the power, not 1, maybe x squared upon x to the power 4 plus 1, or you have something like x squared upon x to the power 4 plus kx plus 1, kx squared, right? Okay, chain rule of what sort, man? So this is what you're going to have. Eventually, you will be able to convert, or you should be able to convert this in terms of whatever we have just discussed, right? Devraj, yes, a minimum score is required. However, it is not a deciding factor for your rank. Okay. So let's talk about this. First of all, guys, please listen to it. It's kind of important because you need to know how to go about it. So over here, we replace this one by something. What something? Let me tell you. I can write it as x squared plus 1. Now, over here, I'll not directly divide it by x squared, Pranjal. See, in this case, x squared plus 1 minus x squared minus 1 upon 1 by 2. Can I write 1 like this also? Can I write this like this, guys? Yes or no? I'm just talking about the first one. I can write it like this, right? Because this x squared gets cancelled out. 1 plus 1 gives me 2. I've divided it by 2 because 2 and 2 will get cancelled out. It will give me 1. So exactly this is the way in which we can portray this. Hence, we have written it in two forms which we have already discussed how to solve. Dot dx, obviously, right? And then you can solve this very easily by dividing both numerator and denominator by x squared, and then taking or completing the square in the denominator and taking the corresponding value as t, the corresponding value in the denominator. Same thing could be done over here, as well as over here. If you have taken x squared, you can add and subtract 1. You will have your result. Okay. Let's take up few JEE questions on this. So one is the question which is there on board. I is being given to us something like this. J has been given to us as something like this. Then for an arbitrary constant C, the value of J minus I equals what? Chain rule. Mayank, there is no sort of, which chain rule are you talking about? In integration, there is no chain rule defined properly. If you want to define chain rule in integration, you may. However, chain rule primarily is applicable in differentiation. Right? If you're talking about biparts or any other thing, then the things are different. Okay. And chain rule in integration is just the substitution story. That's it. Devraj, it's your call. If you are, that's amazing. You can stick around with the same. There is no point going ahead with JEE Advanced. If you want, you may. So let's have a look. Over here, first of all, we'll convert this J in proper positive parts. Let's try and do that first of all. So I'll say, look, J can be written as e to the power minus x. This e to the power minus x is 1 upon e to the power x, right? And this e to the power minus 4x can be written as 1 upon e to the power 4x plus 1 upon e to the power 2x plus 1. If I take the LCM over here, e to the power 4x will be the LCM. So that turns out to be e to the power 4x divided by e to the power x in the numerator. In the denominator, we'll have 1 plus e to the power 2x plus e to the power 4x. Therefore, we can write J very clearly as e to the power 3x upon 1 plus e to the power 2x plus e to the power 4x. This is what the value of J is. Now, the question asks for J minus I. They'll calculate J minus I. J minus I will be what? This is e to the power 3x minus. Look, if you see, the denominator in J and the denominator in I are exactly the same. So we can directly write e to the power 3x minus e to the power x over here. Minus e to the power x divided by 1 plus e to the power 1 plus e to the power 2x plus e to the power 4x. This is what the question is asking for. You can take e to the power x as common and then e to the power x as common. And then you can take, I'm just changing the sequence, dot dx, and then you can take e to the power 4x plus e to the power 2x plus 1. No. Before that, let's remove e. We can take e to the power x is equal to t. E to the power x is equal to t to get something which we already are familiar with. Though this is not required much, but still, we can do it to get something which we are very, very familiar with. So over here, we can say this is t squared minus 1 upon t to the power 4 plus t square plus 1. And this is something which we have just discussed. We can divide both numerator and denominator by t squared to get down to the answer. Devraj, just connect with me on Teacher Connect app. If you are there with Meritnation, we can have a conversation on that afterwards. So this can be rewritten as, what will be the final substitution, guys? Can anyone tell me what will be the final substitution? Obviously, we'll have 1 over here. If I divide it by t squared, this will give me a 1. Directly, I've just changed the sequence. So this can be written as 1 minus 1 upon t squared divided by, let's move to a different screen altogether. Right, so it was 1 minus t squared upon this. We already know the process. So we'll write this as t plus 1 upon t whole squared, right? Completing the square method, t square plus 1 upon t square can be written as t plus y plus, because we have a negative in the numerator. T plus 1 upon t whole squared minus 2. There was a plus 1 already. Minus 2 plus 1 already. Very nice. So in this case, we'll say that the final outcome, which we're going to have over here, will look somewhat like this. And then we can assume whatever is within the bracket as some u. We can assume this as some u. This gives us 1 minus 1 upon t squared times dt. This is dt, sorry. This is not dx. dt is equal to du, right? So you will eventually have du upon u squared minus 1, u squared minus 1. And this is easy to calculate now. So this turns out to be 1 upon 2 ln u minus 1 upon u plus 1 plus c. You just need to replace the value of u, which is given over here. So I'll just do it over here. I hope this is fine. From next session onwards, so u can be replaced. It's t square minus 1 upon t squared. T square minus 1 upon t squared. That is the value of u minus 1 upon t square minus 1 upon t square plus 1 plus c, which will give you half of ln t squared t square minus 1 minus t squared upon t square minus 1 plus t squared. Oh, I'm so sorry. This was not u. U was t plus 1 upon t. That was derivative of it. T plus 1 upon t. T plus 1 upon t. So this turns out to be t square minus t plus 1 upon t square plus t plus 1. And then eventually we'll substitute t. T was assumed to be e to the power x. So the answer to the question turns out to be e to the power 2x minus e to the power x plus 1 upon e to the power 2x plus e to the power x plus 1 plus c. So you're going to have your answer over here. If I just switch to the question again, the options, what is the answer? That was negative on the numerator. Yeah, the answer is C. I hope everyone is clear with it. Right. Last question, which we can see over here, is sort of like this, which can again be evaluated by the same logic. I'll just give you a hint on how to go about this question. It's a very, very simple question to go about. IIT 1998. So you will find that you're going to have such types very frequently. So this can be written as tan x plus 1 upon square root of tan x dot dx. Right. Over here, you can very easily assume tan x to be some t squared, tan x to be t squared. That will give you, Mahesh, you can refer to the recording. Sec square x dx is equal to 2t dt. Right? Sec square x can be written as 1 plus tan square x 2t dt. Therefore, dx can be written as tan square x is t to the power 4. So it is 2t upon 1 plus t to the power 4 times dt. This is what dx is. Then we'll replace the values. So we know the same integration turns out to be t square plus 1 upon, this is t because the squared square root is this. This is 2t upon 1 plus t squared dot dt. T and t gets cancelled out. 2 can be taken outside. And then what we are getting is, oh, sorry, this is t to the power 4. So whatever we are getting, we have already solved this question once. It's twice of t squared plus 1 upon t to the power 4 plus 1 dot dt, which you can solve further, right? Very easy. Again, the same substitutions, divide by t squared, and then take corresponding value of, in this case, you will take t minus 1 upon ts. So divide numerator and denominator by t squared, and take t minus 1 upon t, in this case, as u to solve it. Okay. So that's all for the day. You can try this question on your own. That's all for the day. If you want to know more about your preparation or how can we help to boost up your preparation, you can just visit this URL and see how we can probably help. Yes, Pranjal, I do remember you. And I'm really glad that you are here in the session. In advanced yet, usually Devraj, that is not the case when you're talking about JEE Advanced. In JEE Advanced, usually we get options which are pretty critical to be differentiated. However, in JEE Mains, you can differentiate the options to get the corresponding integrand, and then you can cross-verify and check the answers. All right. So bye, guys. Take care. Have fun. And good luck for your exams. Do take mock tests because they are also important. The information is there on the JEE website. You can go ahead and take mock tests on JEE, which are kind of practice tests in the official JEE centers, right? Okay. Fine, guys. So take care. Bye and see ya. Thank you.